Hello again, this is Mark Armitage coming to you from the microscopy facility in the biology department at California State University, Northridge. We wish to acknowledge the Keck Foundation and their financial support for the production of these videos. We also want to acknowledge Nikon Microscopy University for the images which we're going to show you today. We will begin again with an overview of the confocal microscope, the Leica SP, and then we will delve into more specifics about individual components of the microscope. To initialize the confocal microscope, you must first apply power to the microscope and to the computer which drives the software. You also would apply power to the lasers, but we will hold off on that until another segment. The Leica confocal microscope has at its base an inverted microscope. Now, previously we discussed an upright compound microscope. And so we discussed the illumination path, we discussed the optical path, and here with an inverted microscope, everything is reversed. Everything is upside down from the upright microscope that we worked with previously. For example, the optics are below the stage. So all the objectives that you use for imaging are below the mechanical stage. The condenser is above the stage. Before, the condenser was below the stage and the optics were above. These are reversed now. The transmitted light illuminator is now above the stage. And so instead of transmitting light through the base for bright field and other forms of transmitted light microscopy, we transmit light from above and down through the stage into the optical system and into the body of the microscope. We discussed Epi-illumination, which is light from above for the fluorescence microscopy application. Here we have an illuminator which is supplying the fluorescent light, and again it comes in below the stage. It is epi in that it does come through the optics and reflects off the specimen and back down through the optics and then transmitted into the microscope. But it is reversed because this is an inverted microscope. The transmitted light illuminator has a lamp house back here, and this is where the halogen 100-watt bulb is. When you turn on the microscope, this bulb is on all the time. And so in a few minutes I will show you the intensity control switch to turn down this bulb so that it's not burning all the time. The light comes out of the lamp housing and it goes into a collector system. There are two flip switches here, but those you don't need to play around with. We'll discuss those later. The light comes through this device and comes down into the condenser. Now the condenser does what we talked about previously. It condenses the light and so that it goes into and through your specimen on the stage and into the optics. It is very, very important to align this condenser properly. And we will be showing you two alignment tools that go into these little slots to align the condenser in this plane. This is a knob then that allows us to raise and lower the condenser so that when we align our field diaphragm, it's nice and sharp in the field of view. And so the field diaphragm on this microscope is manual and it's located here. And so we would close this down and open it up so that we could see it in our field of view. And so we're going to discuss condenser alignment specifically as we did on the upright compound microscope, aligning the condenser, closing the field diaphragm, and then using the alignment tools in here to align the field diaphragm to the field of view. Another important feature of the Leica SP, particularly related to inverted microscopes, is that the illumination arm can rock out of the way. And this is important because often we work with large culture dishes that fit in here on the stage. And so with an inverted microscope, we have the ability with stage inserts to use multi-well dishes within which we grow cells. So if you're culturing cells, you can use a small dish that will fit into this space, or the entire insert will come out and you can use larger dishes, or we can purchase additional inserts to accommodate the kind of specimens that you're working with. The other feature of this insert is that it allows you to close these sliding holders down so that you can put your slide in there for observation of specimens on glass slides. The mechanical stage on the Leica microscope is motorized. There are motors that drive this stage in X and Y. And so that's another important reason why the condenser has to be rocked out of the way, because when you initialize the microscope, the computer will drive the stage in X and Y to its end point because of the motors that are on each axis of the stage. So be aware that this is a robotically controlled motorized stage which can injure your fingers. You could actually lose a finger if you put your hands in here while the stage is moving. Below the stage is the nose piece, which holds all of the objectives. And you can see that there are quite a few objectives on this nose piece. This is a motorized nose piece, but we will be manipulating it manually to choose the different objectives that we work with. Later on in this sequence, we will discuss every objective on here, the magnification of it, and the particular parameters of each of the objectives. Several of them are immersion objectives. They might be water immersion, glycerin immersion, or oil immersion, and we will discuss all these at length. It is very important to keep in mind that before you initialize the mechanical stage, you dial the objectives out of the path. It's usually best to dial it to this blank spot. That way all the objectives are below the stage and protected when you initialize the stage and the motorized function takes over. Pay close attention to the nose piece as I'm going to actuate the focus drive on the salt and pepper shaker, and you can see as I manipulate the focus drive, the nose piece goes up and down. This is very important to understand because you can very easily and quickly drive the nose piece into your specimen that's held in place above the nose piece. So take particular care when you're using the salt and pepper shaker to get the right focus. Please understand that the table that supports the microscope is an air table. It's designed to reduce any vibrations that come from the building or traffic outside. If you press on the table, it will decompress and come back up. But we don't want people leaning on the table because that over exercises the air pump that keeps the air under the table in order to reduce vibrations.